Okay, class, picking up where we left off at. We have set A is a set of all elements X such that X is a month that begins with the letter M. And we want to use the roster method. So we would do set A is equal to, we'll put our brace, and we will put all of the months that begin with the letter M, which is March and also May. And we're done. Okay, now scroll to the next page, which is the empty set. It says example, express set F is equal to all the elements X such that X is a font that speaks using the roster method. Then we come to this next example, express set N such that all elements X is a number greater than 15 and less than 6 using the roster method. Now we know both of these are impossible. We know that a font does not speak, and we do not have a number that's greater than 15 and less than 6. So it says here, what do you notice about these two sets? That they do not have any elements. Sets such as these are called the empty set or the null set. Now this is how you can express the empty set. The empty set, also called the null set, is a set that contains no elements. The empty set is represented by the braces with nothing on the inside, or it looks like a zero with a slash through it. The empty set is not represented by, you cannot combine these two. If you combine these two, then it does have an element of the empty set, which would be incorrect. The empty set is also not represented by this here where you put 0 inside of a set. And this notation represents a set containing the element 0. It says which one of the following is the empty set. Now we know that this is not, we have 0, which is not the empty set, and then we have X such that X is a number less than 5 and greater than 8. And then we have X such that X is a triangle with exactly 5 sides. Now, it says here X is a number less than 5 and greater than 8. Actually, class, there is a slight little error here. It's supposed to be, this is supposed to have the word or, not and. Because technically C and D would be the correct answer, but we were supposed to only pick one of these as the answer. So this word and should have been or, so then this would not be the empty set, and D is the final answer because there's no triangle with 5 sides. All triangles only had 3 sides. So now we have notations for set membership. There are 2 notations that are used to show whether or not a given object belongs to a set. The notations, and we have the symbol, this here is used to indicate that an object is an element of a set. The symbol is used to replace the words is an element of. So when we see this, we would say this means is an element of. The symbol, and you notice we have a line through the element of, is used to indicate that an object is not an element of a set. So this symbol is used to represent the words is not an element of. Okay, now it says determine whether each statement is true or false. Now we have P is an element of this set here. If you notice, this is going to be all of the alphabet. So this is true because P is a part of the alphabet. Now we go to B. 8 is an element of this set here. We notice that this set stops at 5 and it goes 1, 2, 3, 4, 5. So that's false. Now we come to C. Oklahoma is a set of, and we have, this is one of the 50 states of America. That is true. Because this lists all 50 states of America. And then we have we have the set of A is part of the set of A and B, and this is also false. The only way that this could have been true is if it would have done this here. If the A would have been listed as this here, and the B would have been listed here, then it would have been true. But since it is not, it is false. Now we have the set of natural numbers. It says numbers used for counting are called the set of counting numbers or the set of natural numbers. The set of natural numbers is represented by the bold-faced letter N. And we have the set of natural numbers or counting numbers is N is equal to 1, 2, 3, 4, 5, and so on. Note the 3 dots or ellipses after the 5 indicates that there is no final element and that the listing goes on forever. Now, example, express each of the following sets using the roster method. Set A is the set of natural numbers less than 7. So we would do A is equal to, now I say the set of natural numbers less than 7, so we know that that will be 1 through 6. Okay, now we have B. Set B is the set of natural numbers greater than or equal to 42. Okay, again, set B is the set of natural numbers greater than or equal to 42. I created a little bit more space here that I'll be able to write this out. And also I did make the braces just a slight bit better. Okay, so now let's go through this. First of all, it's greater than or equal to 42. So we would have set B is equal to, we draw our brace, and we would start with 42 because it's greater than or equal to 42. So we can go 42, 43, 44, 45, and we can do our ellipses to let us know that this goes on forever. Now we have C. We have E is equal to, and write X is the element of, X is the element of a natural number, and X is odd. So we need to write this as E is equal to. Now, since X is a natural number and X is odd, what we would do is this here. We could write out the set of odd numbers that are also natural. Like for instance, 1, 3, 5, 7, and then so on. And that will be our final answer. Because remember, the elements of E must be odd and also a set of the natural numbers. Now we scroll down here, inequality notation and sets. Inequality symbols are often used to describe sets of natural numbers. Example. Now we have a few sets here that basically shows what each of these elements mean. Like for instance, we have X is a natural number less than 4. So we have these elements of X. X is a natural number that's less than 4. And we will write as a roster method. Now we have the inequality symbol and meaning here. X is less than A. And then we can write that here. And we have X is a natural number and is less than or equal to 4. And we show it here. And so on. Now you can look at all of this at your leisure. Now it says example, express each of the following sets using the roster method. Now we have X is a natural number that's less than or equal to 48. So then what we would do is this here, as far as the roster method is concerned, we could write this as 1, 2, 3, 4, 5, and we could put in our ellipses to 48, and this is our final answer. This is all the values of x that's less than or equal to 48, which is also a natural number. Now here we have the same thing. X belongs to the natural numbers. It's a set of the natural numbers. But x is greater than or equal to 25, but less than 55. So what we would do is this here. That means 25 is our lowest number. We'll go up to 29. We'll do our ellipsis. And you notice here that it's less than 55. So we will go up to 54. And that will be our final answer. So these are all the natural numbers that x are supposed to represent from 25 to 54, which is less than 55, but greater than or equal to 25. Now we come to cardinality and equivalent sets. The number of elements in a set is called the cardinal number, or cardinality, or the set. Definition of a set's cardinal number. The cardinal number of set A represented by n of A is the number of distinct elements in set A. The symbol n parenthesis A is read n of A. Note, repeating elements in a set neither adds new elements to the set nor changes its cardinality. Find the cardinal number of each set. Remember to use proper notation when answering. Hint, n of A is equal to. Now for A, we will have n of A is equal to, if you notice here, we have 6 distinct elements, so it's 6. Here we have n of B, and we have 1 as the elements. Now we come to n of C. Now if you notice, we have 11, 12, 13, 14. We have our ellipse 20 and 21. If you notice, the set are going by 1. So we have 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So then that would give us 11 elements. Okay, and finally D. Now if we look here at D, we have the null set. So basically we would have n of the null set, and we know it has no elements or just 0. Now, it says sets that contain the same number of elements are said to be equivalent. Set A is equivalent to set B means that set A and set B contain the same number of elements. For equivalent sets, n of A is equal to n of B. Determine if the following two sets are equivalent. It says here x is a vowel, and x is the natural numbers that are less than or equal to 3 and less than or equal to 7. So let's list the vowels here. We could do A is equal to, and list the vowels we know is A, E, I, O, and U. And then here with these natural numbers, we have B is equal to, we will have 3, 4, 5, 6, 7. Now we count. We have 1, 2, 3, 4, 5. So n of A is equal to 5. And then we have n of B, which is equal to 1, 2, 3, 4, 5. So yes, they are the same. So that's true. So n of A is equal to n of B. And that will be our final answer.